Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on loss of energy in pipe flow. And for that, I have taken a question. An oil of specific gravity 0.7 is flowing through a pipe of a diameter 300 millimeter at the rate of 500 liter per second. Find the head lost due to friction and the power required to maintain the flow for a length of 1000 meter. And consider the kinematic viscosity as 0.29 stokes. So let's consider a pipe through which the liquid is flowing, and suppose this is the pipe is there, and through that the liquid which is flowing, the liquid is nothing but oil. So oil is flowing through this, and which is a length of here 1000 meter is given, and diameter of this pipe is given 300 millimeter. So we can write this is 0.3 meter. Okay, so let's write down the data given for this. So data given is nothing but specific gravity 0.7. If specific gravity is given, means we required some in terms of some density. So density we can calculate 0.7 into 1000. So this is nothing but 700 kg per meter cube. And next is diameter is given, D is given 300 millimeter. So D 300 millimeter means we can write in terms of meter, that is nothing but 0.3 meter. Similarly, the Q given, the rate of flow is given 500 liter per second. So this also we can convert into meter cube per second. So this is nothing but divided by 1000. So we can write 0.5 meter cube per second. And now next is we need to find out the head loss due to friction. So HF we need to calculate. So HF equal to, we know the formula, 4F LV square by 2dg. So this is the formula as per the Darcy-Weber's equation for the major loss, the loss due to the friction. So same things we need to find out. And now the length is given, L is given 1000 meter. And this is head lost. Another one is power required to maintain the flow. So power also, another one formula is there. So this is P equal to, we can write rho GQ HF, rho GQ HF by 1000. This is the power required to maintain the same flow. And here the kinematic viscosity, that is nu equal to 0.29 stokes. So this also we can convert into in terms of meter. Anyway, so first of all we need to find out this head lost. So head loss is this formula is HF equal to 4F LB square by 2gg. Now F is not given, L is given, V is also not given. We need to identify D value given, G is also known. So first let's find out the V value, because we know that V equal to Q equal to, the formula is rate of flow equal to area into velocity. So we can write here velocity equal to Q by area. So Q by area is nothing but 0.5 divided by area, pi by 4 d square. So we can write pi, this 4 we can take it to numerator, pi by 4 d square. D value is 0.3 square. And for this, let's take this help of this calculator. So 0.5 into 4 divided by bracket start. This is pi into 0.3 into 0.3 bracket close. So 7.073, 7.074, let's write meter per second. This is the velocity. Okay, now to find out this F, we know we have to identify first the Reynolds number, because based on the Reynolds number only the friction factor will be calculated. So let's find out the RE value. So Reynolds number equal to, we know the formula, rho VD by mu, but here the rho value is not given, or mu value is not given, rho value actually known. So what we can write, or else we can write this is VD by nu value equal. So we can write, so VD already calculated, so this is 0.07 into D value is 0.3, and this is D, let's write small d, no issue. and new value already written, so that is 0.29 into 10 to the power minus 4 in terms of unit meter converted. So now let's find out this Reynolds number, how much. This is the velocity value, multiply diameter 0.3 and divided by 0.29. So 7.317 into this 10 to the power minus 4 is there in the denominator. You can take it to the numerator, so that will be 10 to the power 4. So this is the value of Reynolds number. Now from this Reynolds number, we can identify the flow is what? We can say the flow is turbulent. So for turbulent, the friction factor value will be F. So the F value will be like 0.079 and divided by Re to the power 4 and the whole to the power 1 by 4. So this is the formula, Re to the power 1 by 4, actually not here 1 by 4, Re to the power 1 by 4. So this is the formula for friction factor calculation when the flow is turbulent. If the flow is laminar, then we can use the formula of 16 by Re. So again, we need to find out this value 0.079 and divided by Re 7.3. Let's write 2, this one, and this is 10 to the power 4 to the power 1 by 4. So this one also you can identify. So this is the value. This one multiply this, so 73,000 something. Now this one again will do one thing, to the power 0.25, 16.44. So let's write down 0.079. This is 16.44. Now what we'll do? So 0.079 divided by 16.44. So 0.0048. So the value we got here 0.0048. So this is the value of friction factor F. Now F we got means most of the things we got in the head loss. So let's calculate the head loss here. So HF equal to, so let's write down 4 into 0.0048 into length is given 1000, and what is the value of velocity? 7.074. So 7.074 square, LV square, and divided by 2 into diameter 0.3, and G value is 9.81. So these are the values. So again we need to calculate this. So 0.0048 already there. Let multiply into 4, multiply into again 1000, and multiply into 7.079, again multiply 7.079 equal, this equal to divided by whole 2 into 0.3 into 9.81 bracket close, 163.64. So the head loss due to friction we got here 163.64, this much meter. Okay, so you can write HF equal to head loss due to the friction is this one. Now we can find out the power value, because everything we got it now. So this is rho G Q HF by 1000. So here all the values we know. Now rho value we need to consider the density of this oil which fluid is flowing through the pipe. So this is 700 into 9.81, and the Q value is already given here 0.5, and HF equal to 163.64 and divided by whole divided by 1000. So this one already we found some value here. Let's see, 163.64 already there. Now multiply with this 700 multiply 9.81, again multiply 0.5. So this much divided by 1000. So finally what we are getting? 561.88. So 561.88, this much kilowatt is there. This is about the power. This much power required to maintain the rate of flow. So this much 561.88 kilowatt. So this is the final answer. So I hope you understand. This is one answer, this is another one answer. The both answer we got it. Now only thing is we need to remember few formulas to identify this answer. As I told you, this is one equation, this is another one equation, like formula which is used for this calculations. So I hope you understand this problem. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.